right? We know that by the time we get to infinity, the factorial is winning. So that's why we can say, kind of in a more general sense, that factorials dominate exponentials. Oops. As n goes to infinity. All right. So now what we can say, right, in conclusion, what we just showed, if that property is true, then that means the limit as n goes to infinity of n factorial over x to the n, right? X could just be any base we wanted that's bigger than 1. That limit will equal infinity because the factorial dominates the exponential. But if I flip the ratio and put the power function on top and the factorial in the denominator, well, then that limit will go to 0. And this will be true for all values of x greater than 1. So right, as long as these are increasing functions, right, this relationship will hold. If I pick a value less than 1, remember we saw that that really just moves it to the other side of the fraction. So that's what we mean when we're saying if you understand how these two things work, because how do you algebraically, you can't take L'Hopital, right? This is an infinity over, you can't take the derivative of a factorial, right? So if you understand that the behavior of this, and then now later we're going to look at some stuff where we're going to tweak this a little bit, but you want to make sure you're recognizing these relationships when we're looking at ratios so you can kind of get an idea of what's going to take over what.
Wouldn't they still be true even if x is less than 1?
No, because the x is the base. So what if I had 1/2, right? Remember we said that's 2 to the n, and that would move it into the numerator.
That would just make it with infinity faster.
Do what?
Wouldn't that just make it with infinity faster?
Oh, you're right. Actually, yeah, in this setup, yeah. So in this setup, it would put it with the infinity term either way. So yeah, this is actually going to work for all x. Good catch. Yep. Does everybody see what he said? So even if it moved in the first one, if I had like 1 at 1/2 to the n, it would just move it into the numerator with the n factorial, and all that stuff's going to infinity already. So the limit would still be infinity. If it's in the numerator here and it's 1/2, it would just drop it into the denominator, and it's still 1 over infinity, so you're still going to get 0. So this is actually going to be true for all x. And if it's 1, right, it still works. So all values of x will work. Except for the first one, you can't have x be 0. But 0 as a base doesn't really make any sense anyway. So cool. So we'll say for all x, let's just be careful, right? Let's not go there. Okay, so this is a good place to stop for the day, and we'll pick back up with this on Monday.